Welcome to solverfy.
In this problem, we have a radio broadcast being transmitted at an unknown power and being received at a distance of 0.65 meters away from the source. And we know that air begins to break down in an electric field of strength 3 times 10 to the 6th volts per meter. And given this information, we want to know what is the maximum power at which this broadcast can be transmitted before we reach that point where air is broken down. So to begin with, we should consider that average intensity is defined as average power divided by area. And in this case, we have a point source, our little antenna here, and it's emanating these spherical waves, and at a certain distance r, all of the power that was originally concentrated at this point is now distributed over a sphere of radius r. And we know that the formula for the area of a sphere is 4 pi times radius squared. And additionally, we also know that intensity can be written as 1/2 times epsilon naught, the vacuum permittivity, times the speed of light c, times electric field strength squared. So we have here some constants, a radius, which we know, some more constants, and an electric field strength, which we know. So if we rearrange to isolate for power, which is what we're looking for, and just plug in all of those values, then we should get a result pretty straightforwardly. So rewriting, we have average power equals 1/2 epsilon naught speed of light electric field strength squared times 4 pi radius squared, which we can rewrite again as 2 pi epsilon naught speed of light electric field strength squared radius squared. So plugging in our values now, we have 2 pi times epsilon naught, which is a known physical constant of value 8.85 times 10 to the negative 12 joules per volt squared times meter. And then speed of light, of course, is 3 times 10 to the power of 8 meters per second. And our radius is 0.65 meters, and it's squared. And our vacuum strength is 3 times 10 to the power of 6 volts per meter, and that value is also squared. Now, if we plug all of this into a calculator and round to 1 sig fig, we find that our result is 6 times 10 to the power of 10 joules per second, which is equal to 6 times 10 to the power of 10 watts. And that is your answer.